Hello, my name is Umer from Comsets University, and this will be an introductory video to most probably a multi-part video series where we will be exploring the detection and monitoring capabilities of osquery and how osquery can be utilized for incident detection and threat hunting. Now the objectives of this demonstration and this video series will be to demonstrate the utilization of osquery as an endpoint monitoring tool, to configure osquery to detect attack techniques mapped to the MITRE framework. So basically detect adversarial behavior and map it to the MITRE framework to detect specific attack techniques. And lastly, we will implement an attack scenario and I will demonstrate how we can perform detection using osquery. Now, we will not delve too deep into the workings of osquery or how certain attack techniques are being implemented. The main focus of this series is just to demonstrate the monitoring capabilities of osquery and the utilization of osquery as a security tool. Okay, so now when it comes to endpoint monitoring agents, there is an overwhelming amount of options. So there are many agents available, commercial and open source. They may eat up resources. They may require the user to learn some obscure or proprietary language. Now the benefits of osquery is that first of all, it is open source. It was developed by Facebook, open sourced in 2014. It is relatively quite lightweight. Second of all, it is cross-platform, so it works on Windows, Linux, Mac OS, and the most important point is that it uses SQL as a search and query language. So you don't have to learn some obscure language. If you have a good understanding of writing SQL queries, then you can most probably use and configure this tool optimally. Now, since osquery will be the main focus of this series, I would first like to give a brief introduction on this tool. So first up, what is osquery? So osquery is an operating system instrumentation framework. It essentially what it does is it treats the operating system as a virtual database. And this allows us to write simple SQL based queries to extract OS information, hence the name osquery. And the benefit of all this is that it allows greater visibility into the operating system. And this leads us into our next topic, which is the osquery schema. Now, as discussed, osquery treats the operating system as a virtual database. And what the schema does is essentially describes the tables which are part of this virtual database. Each table contains information regarding specific OS functionality. So for example, here we have the users table, and we can see that it provides us information regarding the user ID, the group ID, the username, the description of the user account, etc. Now for Windows systems, it offers us 102 tables, but all platforms considered, I think it offers somewhat like 240 something tables. And this basically gives us an idea of the extensive monitoring that osquery is capable of. And this in turn helps us in writing queries to extract specific or relevant OS information. Now, if you want to use this tool optimally, you need to have a good understanding of the schema because it all boils down to writing multiple subqueries and using multiple join statements to extract information from different tables. So here we have an example where we are querying the processes table. So if you look here, we are selecting the process ID, the process name, the path, and the user ID from the processes table, and I am excluding some processes so that it doesn't clutter up all the results. And we can see that it retrieves all this operating system information in the form of SQL tables. Okay, very good. So now what I wish to do is I wish to add here another column, a username column that gives us the username of the account that this ID belongs to. And we can do that in this way. So this is essentially the same query, except we are joining the processes table with the users table using the user ID, and we are also adding another column, the username column from the users table. And now our query result looks like this. So along with the user ID, it also gives us the username of the process that was launched. Now this is a very basic query, and this example was just to demonstrate the monitoring capabilities of osquery, and the only limitation to the optimal usage of this tool depends on the user's own knowledge of SQL and understanding of the osquery schema. So next up we have the osquery components. So mainly there are two components. We have osquery I, which is the interactive shell. So this is the same shell in which we performed our example. Now the main purpose of the interactive shell is to write queries and retrieve information in real time. So this is mainly used to test out queries and for prototyping and optimizing the queries. So it retrieves all that information in the form of SQL tables. And it uses SQLite, so it uses most of the meta commands that we are used to in SQLite. We can also use the .help command, so it gives us a list of commands that the shell is capable of processing. Now the more important and the more crucial component is osquery-d, which is the osquery daemon and the query scheduler. And this component essentially allows us to schedule powerful queries that are periodically executed, and it logs the differentials in the query results. And what that essentially means is, so for example, if I have a query scheduled that is being periodically executed and is monitoring for files in a specific directory. Now, the first time that that query is executed, everything is monitored and everything is logged into the log file. So everything is added into the log file. Now, the next time that the query executes, depending on the interval that I have provided, 20 seconds, 30 seconds. So the next time that the query executes, and if we assume that no files have been added, no files have been removed from that directory, once that query is executed again, so there will essentially be no difference in the result of the current query and the result of the previous query. So it will keep on monitoring the system, but it will not generate any logs because there is no differences between the query results. Now, if for example, I add some files to that directory, I remove files from that directory, I change certain file attributes. Now, once that query executes again, it will notice those changes that have occurred, and it will log only those changes that have occurred. And this is what it means by that it logs only the differentials in the query results or the changes in the query results. And all of this ties back to why osquery is such a useful tool when it comes to endpoint monitoring. So for example, if a malware is placed in a specific directory, that malware deletes some files, it generates some file, creates certain processes. So these are changes in this operating system that are occurring, and osquery is very capable of detecting these systematic changes. Okay, then we have the osquery configuration, and this is the configuration that I have utilized in my demonstration. So the config plugin is file system. This essentially tells the daemon to look in the local system for the configuration file, and this is the configuration file in JSON format. Now the logger plugin is file system, and this tells the daemon to log the query results in the local system in JSON format. So all the results are logged in the log directory in a osquery.result.log file. And the more important option is the packs option right here. And packs in osquery are essentially a set of queries. So for example, here I have a file monitoring pack, and this pack will consist of different queries that are monitoring for changes in the files. We have a registry monitoring pack that monitors for modifications in the registry. So it will consist of different queries that are monitoring for certain registry modifications. Similarly, we have a process monitoring pack and a schedule task monitoring pack. So this pack will consist of queries that will be monitoring for schedule task creation. Okay, next, reference detection implementation. So osquery attack is essentially a repository of different osquery configurations and osquery packs that have been directly mapped to the MITRE framework. So as was mentioned in the objectives earlier in the introduction, that one of our objectives is obviously to detect adversarial behavior, but also to map those techniques directly to the attack framework, and for that purpose this is the reference that I have used in my demonstration. So this was developed by Filippo Martini, and again this basically gives us a reference on how we can optimize our queries to detect specific attack techniques. Okay, then the attack scenario that we will be implementing in our demonstration is: first, the attacker places a malware in the victim system. The malware is executed. It initiates a reverse shell connection with the attacker's system. Then we will have file transfer post exploitation. So after initial access, the attacker then will try to download and transfer the different malwares, binaries, and scripts to proceed with his attack. And finally, the main objective of the attacker in this scenario will be to place a keylogger in the victim's system. Now I will also touch a bit on each phase of the kill chain in reference to this attack scenario, except for the reconnaissance phase. So in weaponization, we will see how the attacker generates his malware. We will see how that malware is delivered to the victim, how the malware is executed and allows the adversary initial access to the compromised system, then how the adversary downloads or transfer the different tools and utilities that he requires to proceed his attack post exploitation, how the attacker sets up different means, persistent means of command and control to remotely manipulate the compromised system, and lastly the attacker executing his objectives, which in our case, in our attack scenario, will be the attacker placing a keylogger in the victim's system. And in all these phases of the kill chain or the attack path, we will be using osquery to detect the techniques that are being implemented. So this was it for the introductory video.